Hey, this is Mr. Hansen. We're looking at three ratios of a triangle, three different ratios of a triangle. We want to give them names and kind of identify which sides make up those ratios, and then we want to actually use each of these ratios in a triangle word problem. So here we go. The first one is sine. So I'm going to highlight the two that we use. We use the opposite over the hypotenuse. So opposite over hypotenuse. The second one is cosine. I'm going to highlight that one. It's adjacent. Oh, and by the way, let me mark these angles. We're talking about this angle. So this side is opposite that angle, and then we have the hypotenuse here. Okay, cosine, it's not opposite over hypotenuse, it's adjacent over hypotenuse. So this is the adjacent side for this angle. It's touching it. And that's the hypotenuse there. So cosine is adjacent over hypotenuse. And again, we're going to kind of just highlight these in blue. And the last one is tangent. We're looking at the same type of angle there. And this time it's opposite over adjacent. So let's just label this opposite. This is adjacent. And we'll highlight that. So when you think of tangent, think of, you're just thinking of the legs, the opposite leg over the adjacent leg. Okay, you want to kind of get a visual image of what we're talking about here and keep that in your mind. So sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. One way to remember this is, let's do this in a marker. Let me do it right. There's an old math legend that says that an Indian chief stubbed his toe on a rock and he said, "Sakatoa." And so sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Sakatoa. So hopefully that helps you remember which one is which. Okay, we are going to move to the portion where we actually solve a problem. We've got a doorstop that we've made, and we know it's 8 centimeters long, and it forms a 22.5 degree angle, and we need to consider its height. So looking at this, we've got opposite and adjacent. You might remember from Sakatoa that opposite and adjacent is tangent. So I'm going to write tangent at 22.5 degrees equals the height x over 8. And tangent 22.5 is going to make some kind of ratio. So I'm just going to tangent 22.5. It makes a ratio of about 0.41. So 0.41 for the opposite to 100 for the adjacent. So less than half as big. Now we times that 0.41 by 8. So I'm timesing both sides by 8. That cancels out here. So times 8, and I get 3.31. So the height of our doorstop is 3.31 centimeters. And that's it. That's all there is to it. Let's try another one. This time we are measuring the height of a kite, how high it is in the air vertically. And so we had 100 feet of kite string, and we let it out at a 60-degree angle. And this person is 6 feet tall, so I'm going to put a little 6 right there. And we are looking at, we need the height, which is the opposite, the 60 degrees, and we have the hypotenuse, which is the kite string. So opposite and hypotenuse, Sakatoa, it's going to be sine. So sine is opposite over hypotenuse. So sine at 60 equals h, the height, over 100 I'm just going to type in sine 60 on my calculator, and the ratio is 0.866. So for every 86 units of vertical height, we have 100 units of kite string. That's what it's saying there, 0.866, something like that. Okay, so I'm going to put, in place of sine 60, I'm going to put 0.866 and equals h over 100. Now all I have to do is get h alone, so I'm going to times both sides by 100, and that moves my decimal over 2. So it's about 86 feet from the beginning of the triangle to the end. So 100 times 0.866 is 86.6. That equals the height. And then if you wanted to add the 6 feet, you'd get 92.6 feet tall or high. So that's how high the kite is. Okay, so we've used tangent, we've used sine. This time we've got a ladder, and it's a 16-foot ladder. It's against the edge of a house, and you're supposed to never put a ladder at more than a 70-degree angle. If you did, you could kind of imagine what would happen. You might fall over backwards. So let's see how far we should put this ladder from the house. That's kind of the idea there. So let's see, this is our given information here, and then we need that there. And since both of these sides touch the angle, we're going to use cosine, adjacent and hypotenuse. So cosine at 70 degrees equals adjacent over hypotenuse, so we'll call the adjacent x, over the 16. And the ratio for cosine at 70, I'm just typing it in my calculator, is 0.34. In other words, for every 34 units we have on the short blue, we're going to have 100 units on the hypotenuse. So 0.342. 0.342 equals x over 16. Now you just multiply both sides by 16, and you come up with x. So I'm going to times that by 16, and I get 5.47. So we are about 5.5 feet away from the house. You shouldn't be any more than 5.47 feet, otherwise it starts to get dangerous. Okay, take a good look at this. Take a look, we have a opposite and hypotenuse there. Here's our angle, we have this is adjacent and hypotenuse, which is cosine. Here's our angle. We have opposite, and hypotenuse, which was sine. There's my angle. And we have opposite and adjacent, which was tangent. We were able to solve all three of those. Thank you.